Tonight, we will talk about maximums and minimums. Make sure to put your date on your notes. Very simply, maximum is the highest coordinate of the graph, and the minimum is maybe the lowest coordinate of the graph. It may have one, it may have the other, or it may have neither. We're going to look at this example. We're going to do several things. First, we're going to identify the function. Hopefully you know that this is called a parabola, which is a quadratic function. Here's a function. Now you can see it stops right here. That's right about there is the highest point. Okay, so this one has a maximum. And we indicate the maximum by the coordinate that's there. So we can probably say that this is at, let's see, 1.5 and I don't know, call it 6.8 or something like that. Okay? So we'll say 1.5 and 6.8 is about the maximum. Okay? I also want to keep working on domain and range. So domain, we look to the left and the right. It's the x-axis, right? So I look at this and I see it going in direction in the left and the right. Arrow indicates forever. So domain is all real numbers. The range is the y-axis. So when I look at the y, I can see that the graph doesn't go above this point. It's this point and below, and it goes down forever. This point has to be the y of that coordinate. So the range would be y is less than or equal to 6.8. Okay? So you can see part of the maximum should also be part of your range because it is the topmost point. Okay? Let's look at one more example. This, hopefully you remember from your notes last night, is called an exponential function. Okay? It makes the swoop. It's increasing. Remember we wrote left to right, it's going up. So it's an increasing exponential function. And you can see it goes up forever and it goes to the left forever. So this does not have a maximum or a minimum point. Okay? And the reason we can say it has no minimum is, although this looks like it's staying at the 1, this is called an asymptote. We're going to learn more about this later. And what that asymptote means is this line gets forever closer to 1, but never reaches it. Okay? So it's getting closer, and it might be at y equals 1.1, 1.01, 1.001, and so on. It hugs this y equals line, but never quite touches it. That's called an asymptote. We're going to spend some more time on that later on in the school year. But there's no top point and there's no bottom point, so this doesn't have one. For our domain, we can see we look left and right. To the left, it goes forever, and it's increasing towards the right forever. So again, for the domain, we'll say all real numbers. And then for the range, here is my y. Okay, I didn't draw that very good. That's y equals 1, right, on the y. And we said this is an asymptote, so if forever comes along this y, it gets microscopically closer to the 1 on the y, but never actually reaches it. So for here, we say y is greater than 1. We don't ever say equals to because technically this 9 never hits the 1. Even though it kind of looks like it's on there, it's never on the 1. So y1 is the lowest it goes, and it increases forever to the top. But it never quite touches that 1. So the only difference here is we don't put the equals to there. Okay? So lots of things to remember. We need to remember all our function families. We need to see if there's a maximum or minimum. And we need to do domain and range. Okay? So I'm going to have you do one on your own. Okay, so for this one, just look to the questions to the right and see if you can figure out the correct answers. And may the force be with you.